Guys, let's go ahead and solve this question. Now the question is to evaluate the integral of the square root of tangent x all over by sine x multiplied by cosine x dx. Let's begin. Now in this question, the first thing to do is to rewrite some terms using our trigonometric identities. Now from this question, this term here, let me write it separately. 1 over sine x multiplied by cosine x. This is just equal to secant square x divided by tangent x. Well, I will show you why this is true. Okay, for those of you who know what is secant, when you say secant x is 1 divided by cosine x, isn't it? Let's prove this. Then we have 1 divided by cosine x. We have a square there, secant square, so let's square it. So this is the same as secant square divided by tangent x is the same as sine x divided by cosine x. So we should know our trigonometric identities. Well, this is the same as 1 divided by cosine square x divided by cosine x, isn't it? Now from here, we can see that cosine x, because here there are cosine square x, then it will cancel the 2 out. So we have only 1 cosine x over there. Then by rewriting this, because we have 1 over cosine x divided by sine x, that is the same as 1 over cosine x multiplied by sine x. Or you can say 1 over sine x multiplied by cosine x, because multiplication is commutative, so it doesn't matter whether sine x multiplied by cosine x or cosine x multiplied by sine x is the same. So I just wanted to show this. I think this is clear. Now you agree that 1 over sine x multiplied by cosine x is equal to secant square x all over by tangent x. Okay, let's clear this and then continue with our question. Now that being said, in our first step, we are going to have the integral of the square root of tangent x, okay, multiplied by secant square x all over by, yes, secant x square all over by tangent x, what I just showed in the example there, dx. Okay, so I think we all agree that 1 over sine x multiplied by cosine x is the same as secant x over tangent x. Okay, then from here, well, we have tan and then tan. Remember, the square root of tan is the same as tan x raised to the power of half, isn't it? Sorry, it's just like tangent of x all in bracket half. So if we bring this half below, like if we bring it at the denominator, the sign of half will change to negative half, isn't it? So because here the exponent is just 1, so if we bring down the square root of tangent x, remember it will be minus half. So 1 minus half is half. So meaning we are going to have tangent x of half, 1 over 2, in the denominator. I don't know if this is clear. Let's go ahead and do that. So we are going to have the integral of secant square x divided by the square root of tangent x dx. I want to show this to those of you, for those of you who might not understand what I'm trying to say. Let me solve it here for clarity. Over tangent x. This is the same as, I'm referring to this, okay? So this is the same as tangent x. Tangent x raised to the power of half, then tangent x, okay? By bringing it down, this will give us 1 over tangent x multiplied by tangent x raised to the power of negative half. Remember, when you take this up, the exponent changes to negative, and when you bring this down, the exponent changes to negative. So that gives us 1 over, because the exponent of, that gives us 1 over, because the exponent of tangent x is 1. 1 minus half is just half. So that is tangent x raised to the power of half, which is the same as the square root of tangent x. I think this is also clear. I don't want to leave anything unclear. Let's move on. Sorry. Oh my god. Let me try that again. Okay. Let's continue with our question. Now from here, what can we use? Let's think. Well, we can use a substitution here. Let's say, let u be equal to tangent x. Okay? We got tangent x here. Let u be equal to tangent x. Well, then du will be equal to, yes, that's true. I think we all know the derivative of tangent x, right? It's just secant square x. Of course, the x, because we are differentiating with respect to x. I think everyone knows this. We should know our trigonometric identities for this question. Yeah, because there are a lot here. We have to apply them. Let's continue. Well, looking at our integral, we do have secant square x dx, isn't it? Then therefore, this can be replaced by this, isn't it? Yes. Let's go ahead. Let's finish the question around here. Then we have the integral of, now instead of secant square x dx, we are going to have du. So we have du all over by, well, we have the square root of tangent x. Then we say let u be equal to tangent x. Then in the denominator we'll have the square root of u. And this, is the same as the integral of u raised to the power of negative half du. All I do is to convert the square root into a half and then take it to the numerator. It changed to a negative half. Well, as calculus students, the antiderivative of this is just what? We have u. Negative half plus 1 gives us how much? Well, negative half plus 1 is just half, positive half, okay? Then we divide this by half plus the constant c. And this can be written in the form of 2, the square root of u, that is u raised to the power of half is the square root of u plus c. Well, is this the final answer? No, because in our question, in this integral here, there is no u. So we should not forget to return tangent x, because u is equal to tangent x. Let's replace this u by tangent x. Then therefore, this is just 2 square root of, instead of u, we have tangent x, okay, plus c. And this is the final solution to this integral question. Now, if you like this video, please consider subscribing to my channel, like, comment, and share. Thank you for watching this video.